In this video, we're going to take our existing configuration where we have two hosts, which are connected to shared storage and which are configured for vMotion. We're actually going to create a distributed resource scheduler cluster, which will automate the process of placing virtual machines when they start. We can determine which node in the cluster should start that virtual machine based on load factors, both current and historical. As the machines are brought online and as workload is actually generated and as workload usage patterns change, well, you might find that that initial placement, of course, is not necessarily the appropriate placement the next hour, the next day, or the next week. So using the distributed resource scheduler, we can actually automate the process of using vMotion to transfer machines while they're running between the hosts that make up the cluster, again, based on that current and historical statistical workload analysis that the distributed resource scheduler does. So I've got my Lab Environment 1 data center. What I'm going to need to do is create a cluster object inside that data center. All the hosts that are going to make up the cluster need to be within the same data center, unless we start talking about things like Site Recovery Manager or something. But for DRS purposes, they're all going to be treated as a local site effectively. So I'm just going to right click and say New Cluster. Now you'll see we also have an option to turn on vSphere HA. That's going to be the subject of another video. I'm going to call this Cluster 1. Now, the major difference between DRS and HA is that HA is really designed to restart virtual machines when a host running that virtual machine fails, to automate that restart process, or also to heartbeat that virtual machine, and if it's hung for whatever reason, or if it seems to not be responding, then to do a restart of it as needed. So you'll see we have a couple of options here in terms of automation level. Manual, partially automated, or fully automated. If we place the cluster at automation level manual, then actually nothing will happen automatically, as the name implies. Whenever we start a virtual machine that's part of the cluster, we're going to need to select a node manually every time we turn it on. So that might not match the exact process used to start large numbers of virtual machines now. I generally wouldn't use that. You'll see we also have partially automated, in which case the initial placement when the virtual machine is powered on will be made based on the statistical load factors, but nothing's going to be dynamically moved around using vMotion, except it will generate recommendations of where you might want to move things around using vMotion, and then we can actually do that using a simple one-button application. And then you'll see we also have fully automated. So with the fully automated level, you'll see we actually have multiple migration thresholds within that, from the conservative side over to the aggressive side, and basically each one of these levels will have quite different behavior. So if we talk about the most conservative settings, what it will do is it will only apply the various rules that you've defined as part of DRS. We can specify rules that keep virtual machines together. We can also specify rules that keep virtual machines apart. In an HA type scenario or something, sometimes those rules might be validated, or if we were to manually migrate something, depending on how strict those rules are and so on and exactly what we've defined, the placement might not be exactly as we prefer. And when those rules get applied, then we can have that just take effect. But that's all that it does, and the rest will just be based on recommendations that we can apply manually. And then as we increase, you'll see that it starts automatically applying priority 1 and priority 2 recommendations, which they say here promises a significant improvement in the cluster's load balance. Now, that might not be on a virtual machine by virtual machine basis. This may actually involve movement of a whole series of virtual machines in order to make the appropriate level of room. So it's really quite advanced and quite interesting to see it operate in a large cluster, which unfortunately can't really simulate here, but a very interesting feature. As we move up, we'll see it applies priority 1, 2, and 3 recommendations for a good improvement to the cluster's load balance. The next level up offers a moderate improvement, and the next offers a slight improvement. So in this case, I'm just going to click Next, and you'll notice I've got all the power management options, but we'll come back to that. So it asks me about whether or not I want to enable enhanced vMotion compatibility. If I have CPUs that have this capability, VMware can direct the hardware to set for a particular system profile, effectively representing itself as a different CPU, lowering the instruction set capability that it's going to use to the lowest common denominator in the cluster, to make sure that these automated vMotions can happen effectively without causing any problems or without restricting the number of hosts that we can actually direct them to. If we take a look at, for example, enable EVC for Intel hosts, we can specify whether we would like to act as a Merom generation or a Nehalem or a Sandy Bridge generation or whatever other options are going to be here with future releases for VMware. And for AMD hosts, basically a specific Opteron generation. we have the option to specify where we want to store the swap file for virtual machines that are going to be part of this DRS cluster. So we have the option to store the swap file with the virtual machine or to store the swap file on whatever data store has been designated as the swap for the host. I'm just going to go ahead and click Finish, and we're going to have a cluster object created. Now at this point, I can actually drag and drop my hosts into that cluster if I like. The main thing is whether or not they're configured for proper vMotion, and if we can do vMotion manually, then we should be able to automate it. So I'm just going to take my first host and drag it into the cluster. And you'll see that it says, well, what would you like me to do with all the virtual machine resources and resource pools that you already have? I don't really have any, so I'm just going to say, put it into the root resource pool. I didn't have any resource pools on the original host, and I don't have any in my cluster, although the cluster itself does actually represent a resource pool internally. So now that I have my first host into the cluster, I guess I'll just do that again with my second host. And now we can see that I have a DRS cluster with my hosts in it. The virtual machines are no longer really represented here as being associated with a host anymore. So that's an important distinction. It's a little bit tricky sometimes if, for example, your vCenter server is a virtual machine and you're running it in DRS. Sometimes you can have a little bit of difficulty with that, and we'll talk about some of those issues in a later video. But this gives us a pretty good idea of what it takes to install a cluster, set it for DRS mode, and configure what level of automation we want to have. Later, we'll take a look at configuring rules for DRS and how to generate recommendations and what happens when the recommendations get applied and what happens if we just automate the cluster and start generating workload inside the virtual machines and see what happens.